Okay, so we solve for the tangential deviation at D due to a tangent drawn at A. So it will be equal to the area from A to D. This time, our barred X will be referred from D. Okay, so due to this P1, we have 206.5 times the distance with respect to D. That is 1/3 of 7. So you have 7/3 minus this third-degree curve. 6.75 times the distance with respect to D is 1/5 of 3. So we have 3/5 minus this one, 125 times 1/3 of, kani pa yung diha, 2 plus 3, 5. So that is 1/3 of 5. Okay? And calculating, we have 5,381/20 EI. Okay, so we solve also for TB/A, no? Kani din he. Okay, and that is equal to the area from A to B times part X with respect to B. Okay, so kanira nga area din he. So 1/2 times 16.86 times 2, and the moment arm with respect to B is 1/3 of 2 or 2/3. So calculating, you have 281/25 EI. Okay. Next is, we solve for BB prime. Okay. BB prime is, ano siya? Kanino? Mani ang B to B prime. So by ratio and proportion, BB prime is to 2 as TD/A is to 5. So, mana siya, no? And then, so solving for BB prime, we have 2/5 of TD/A. So we can now solve for delta B equal to BB prime minus TB/A. Okay? So our BB prime is 2/5 TD/A, substituting also the value of TD/A here, minus TB/A to 81/25 EI. So we have 527.66 over EI kilonewton meter cube. Now we are given the values of E and I. So substituting, now since E expressed in 200 gigapascal, so converting that to kilonewton per meter squared, that is 200 times 10 to the 6. Okay, and substituting the value of I, so we have 0.025007 meters. Now, deflections are usually expressed in mm para murag ma-visualize nimo unsa ka kadako ang deflection kay in meter kanilang 0.025 murag lisod imagine unsa na kadak-ano kaysa 25 mm. Okay, so the direction should be also stated kung unsa downward ba upward. Katong atong last example wa nato di ay nabutangi og upward ang deflections. Okay,